So we have looked at this simulation before, and we've discussed how if we increase the amount of solute, then the solution becomes more concentrated. And we can see that that gives us more moles per liter. And we can assign values to that and see that 1 mole divided by 0.5 liters gives me a solution concentration of 2 moles per liter. That's what molarity stands for. Or if I were to put less solute in, we can see the concentration go down. If I were to do 0.378 moles divided by 0.5 liters, we would get 0.756 moles per liter, which is our concentration. And this is true. I just changed it to nickel 2 chloride, or we could have cobalt 2 chloride. So whatever that substance is, that is our solute in moles. Now, we know that solids can have their mass in grams, right? So if I were to look at this simulation, and if I were to take this cobalt 2 chloride, and let's say I was in the lab and I wanted to weigh the mass of a certain amount of cobalt 2 chloride and add it to a certain volume of water, that we would have a concentration in moles per liter. But we don't measure in the lab in moles, do we? We measure in grams. And then we can relate that back to its molar mass and convert from grams to moles. That then allows us to calculate concentration. So here's a potassium chromate example where I have a solid. I can weigh out in the lab in grams a certain amount of potassium chromate. I then need to take my grams and convert to moles. And we can do that by finding the molar mass of 2 potassiums, 1 chromium, and 4 oxygens, and convert from grams to moles using our dimensional analysis. So we have our solute adding to the solvent. And of course, we know the volume of our solvent, and then we can find the concentration. Let's look at our first sample problem and how molar mass comes into play when we are finding the concentrations of a solution. What is the molarity of 245.0 grams of H2SO4 dissolved in 1 liter of solution? So let's look at what we know. This H2SO4 that is dissolved in, that means that this is my solute, and it's dissolved in this liters of solution. So this is my solvent. So this now it wants to know molarity. So molarity, we know, is moles per liter. And this is our moles of solute. Well, I'm given grams of H2SO4, so I need to go to moles. Because I know liters of solution. It's 1.000 liters of solution. Now, in order to do that, I need to find the molar mass of H2SO4. And the molar mass of H2SO4, we're going to use the periodic table, and we're going to add up 2 hydrogens, 1 sulfur, and 4 oxygens molar mass. So we always use the periodic table. I'll just say PT. Use the periodic table and look up the chemical formula to find this. And if I look that up and add up 2 H's, 1 S, and 4 O's, I should get 98.0768 grams for every 1 mole of H2SO4. And remember, I can also say that 1 mole of H2SO4 has 98.0768 grams of H2SO4. Why don't you pause and go and double check to see if you get the same answer? Okay, so we've got 2 different ratios here. Which one am I going to use? Well, I'm starting with 245.0 grams of H2SO4. Our question wants us to find the molarity, which is moles per liter. Well, if I've got grams, what do I want? I want moles. What have I got? I've got grams. So we need the ratio with the moles on top and grams on the bottom, which would be this guy, right? So 1 mole over 98.0768. That way, grams and grams can cancel out. So can you pause the video here and do 245 times 1 divided by 98.0768, and let's see what we get. My calculator gives me this answer, 2.49804,235, and that would be moles of H2SO4, which is my solute. All right, now remember, molarity is moles per liter. So now we're going to plug in the moles that we just found, the 2.49804,235 moles of H2SO4 divided by how many liters of solution? The 1.000. And I started with how many significant figures? 4 significant figures there, 4 significant figures there. So I want to end with 4 significant figures. So 2.498, and we label molarity capital M, which stands for moles per liter. All right, great job. Now this is a question that you are going to see on the Your Turn question. So why don't you try writing it out? It's very similar to the one that we just did. Write it out and save your work to make the Your Turn assignment easier. I will give you one little hint about this. Sometimes people get confused and they say, well, what about the solvent amount? Well, notice that it says per liter here. So we are assuming that we have 1 liter, because if we said it's something per liter, we just assume that that's a 1 or a 1.00. So let's look at one more problem connecting grams to moles and then utilizing the moles and molarity as moles per liter. It is asking us how many grams of NaOH is in 0.500 liters of a 0.250 molar solution. So we know concentration and volume. And remember, we said that molarity is equal to moles divided by liters. Okay, nowhere in there does it get me to grams, or does it? I'm going to write this in the format that I really enjoy. Molarity is equal to moles divided by liters. So we know molarity and we know liters. So what can we find if we know these two? If I multiply these two together, I can find moles, right? And what can I get to if I know moles? If I know moles, I can get to grams, right? Grams to moles and moles to grams. by finding the molar mass of that compound. And we know what that compound is. It's NaOH. So we can look at the periodic table and find the molar mass of NaOH. So let's think about this. I've got a solution. This is my beaker. I'm a terrible drawer. And let's say I've got 0.5 liters, so I have my volume, 0.500 liters, and it is concentrated to 0.25 molar. So again, we know its concentration. We want to find out how much of that NaOH is dissolved in there. So let's multiply our molarity times our volume. So 0.250 capital M. Now capital M stands for, I'm going to erase this. I'm going to show you how the units cancel out. Moles per liter, right? That's what molarity stands for. That's how many moles per liter. And if I multiply that by my volume, which is 0.500 liters, notice how liters and liters cancels out, leaving me with moles, right? We said that moles is equal to molarity times volume, and that's how the units work, right? Liters and liters are diagonal from each other, they'll cancel out. So let's use your calculator. What is 0.250 times 0.5? I got 0.125 moles of NaOH. Okay, now from there, I am going to look at the periodic table and I'm going to add up 1 sodium, 1 oxygen, 1 hydrogen. And I need moles on the bottom. 1 mole of NaOH has a molar mass of 39.997. So I need to do 0.125 moles divided by moles, cancels. 0.125 times 39.997, and it should give me, let's see, my calculator reads 4.999625. That would be grams of NaOH. Next thing I need to do is look at significant figures. I started with 3 significant figures with my volume and 3 significant figures for the concentration. So I want to end with 3 significant figures. 1, 2, 3. Cut it off right there. And that 9 is going to round that up. So I'm going to have 5.00. That would be my 3 significant figures. Grams of NaOH. Remember, how did I get this 39.997? I looked at the periodic table. I'm going to say look at the periodic table to find the molar mass of NaOH, which is 1 Na plus 1 O plus 1 H to get that 39.997. So then, if I wanted to make this solution, I need to, in the lab, weigh out 5.00 grams of sodium hydroxide, have 0.5 liters of water, and if I dissolve that 5 grams of NaOH in that amount of volume, I would have this concentration of a solution. All right, good job.
To make a 1 molar NaCl solution. Now 1 molar means we're going to put 1 mole of NaCl in 1 liter of solution. And if we do the math, 1 mole is 58.5 grams. You add up the mass of 1 mole of sodium plus 1 mole of chlorine, put them together, and get 58.5 grams. Then you fill the flask about halfway with water. This is a 1 liter flask, 1,000 milliliters. Fill it up about halfway, just enough water to get all of the salt dissolved. Now add your 1 mole. If we were making a 2 molar solution, we'd have 2 moles, but here we're just adding 1 mole. Swirl it, try to get it all dissolved. You may have to heat it, but we're pretty good here. And then you're going to add some more water. Now you have to be careful here because you don't want to exceed the 1 liter mark. So you keep adding water quickly until you get close to that 1 liter mark, but you don't want to exceed it. So stop before you reach that point. And then use a squirt bottle or a pipette or a small graduated cylinder and just add a little bit of water at a time. And then as soon as you hit that line, you're done. You now have 1 liter of a 1 molar salt solution.